Hello everyone. In this video we're going to continue to talk about reading the general purpose I/O on the Raspberry Pi in a C program. And in the last video I talked about the polling method, the interrupt method, and went through the circuit we're going to use in this tutorial. But in this video we're just going to focus on the actual program and demonstrate it operating. So let's go ahead and get started. Okay, here we have the program we're going to use in this tutorial. First thing we're going to do, of course, is import the libraries that we're going to use. And if you don't know what libraries are, go ahead and view my video on libraries. And we're going to use the standard I/O library and the BCM 2835 library. The standard I/O library is going to allow us to print to the screen, and we're going to use that to kind of demonstrate how this program works. And then the BCM 2835 library allows us to access the general purpose I/O of the Raspberry Pi. I also defined some values here, some that will be used as constants. I call them LED for the pin that the LED is connected to, and I define that as 18. We have our LED connected to pin 18. I created one called button 1, and because button 1 is connected to pin 19, and I make that equal to 19. Button 2 is 26 because button 2 is connected to pin 26, and I've created one called delay change and set that equal to 500, and that's going to be 500 milliseconds. What this program is going to do is every time we push one of these buttons, it's going to increase or decrease the delay between the blinking of the LED by 500 milliseconds. So that's what that value is going to be used for. And down here, this is something I'm defining as a bit mask, and I'm not going to go over bit mask in this video, but I will talk about that in a future video. So check back or subscribe, and I'll go over bit masks later. So into the main program, I don't have any functions here, but into the main program, first thing we do is initialize the BCM 2835 library, and this is a standard line that you're going to have in any program that you're going to when you use this library. So that does that, and then we set up all of our pins. The first pin we're setting the pin 18, which is we call it LED, to an output, and then on the next line here, we're taking the pin 19, which we called button 1, and we're setting that to an input. And then on the very next line, we are enabling the pull-up on that pin. This is the function to enable that pull-up. And what the pull-up does is it sets that pin at the 3.3 volts. And when we push the button, it's going to take that to ground or take it to 0 volts. I tried to do this with just external pull-ups, and it didn't work quite right for me. One of the things I'm not liking about Raspberry Pi, and I'm sorry for all the diehard fans out there, but the documentation for some of the I guess the hardware design and the circuitry and stuff is closed, and so it's hard to see what's actually going on under the hood. But we do need to enable these pull-ups here for this to work. Next line is the same as the two above it. We set button 2, which is 26. Pin 26 is set to an input, and then on the next line we're going to enable the pull-up for that input. And all of these functions can be found in the BCM 2835 library, and if you go to that, and if you need to look at that library and get more information about it, you just highlight this, and again, I'm in Genie, right click, and say open selected file, and that will bring up the library. But I already have it open, and we can search down through here. I'm not going to do it in this video, but you have all the functions here, and you just click on them over here, and it'll go to the one that you're looking for. And you also have type defs, enumerations, macros, and other. And I'm not going to go into what all this stuff is, but a macro actually, we're actually defining some macros in our program here. These up here, this hashtag define that is a macro. So yeah, we already went through all those. This next line here, this is what is going to enable at least the Raspberry Pi version of an interrupt. And what this is going to do is it's going to set a flag anytime button 1 is detected to go to a low level, or anytime button 1, which is connected to pin 19, anytime that goes to 0 volts, it's going to throw a flag, and that's what this is going to do. Now, I don't know what the threshold is, but if it goes zero volts, it will throw a flag, and we're going to use that flag to say that we've detected an input. The only variable we have in this program is something called delay. It's going to be an unsigned integer. I could just call it delay, and it's initially going to be set at 5,000, and that's going to be the delay in milliseconds. So that's going to be set to 5 seconds. So a millisecond is 1/1000th of a second. So we have 5,000 of them, so that means it's 5 seconds. Okay, and in in most programs, you'll have a forever loop, and this is our forever loop. I'll talk about loops and structures and all that in a future video, but just know that everything that's between this curly bracket here and this curly bracket down here should loop forever. As long as we allow the program to run, that's going to loop forever right there. Okay? Down inside that loop, the first thing that we do here is we're going to check to see if we have detected a button press by button 1, and that's what this does right here. And again, all of these here can be found in the library, or you can go to the website supporting that, and there are definitions given for all of these. So again, this is button 1 is just like sticking the pin 19, I said it was, in there. So if there's been a flag set that button 1's pressed, it's going to enter in and execute these lines. And the first line is going to print to the screen button 1 is on, and then it's going to print the separator here. And then it's going to change the value of the delay variable, and it's going to set it equal to whatever the delay is minus the delay change. Remember, we said delay change is defined as 500. So it's going to subtract 500 milliseconds to the delay and then make it equal again back to delay. So it's going to reduce the delay time by 500 milliseconds. On the next line, we're just going to then reset that flag, and so it can detect another button press. And this is where one of the limitations of the Raspberry Pi version of an interrupt comes in, is that a traditional interrupt, it would we could make it execute this code as soon as the button is pressed. Well, as soon as the processor can throw its current work on the stack and go execute this code, it'll happen. And so we could sit there and push the button over and over again, and it'll just happen. In this program, what you'll see in a demonstration is we can only push the button one time. It'll only detect one button press for every loop. And so if we have a 5-second delay, we could push the button 10 times in that 5 seconds if we're really quick, and it's only going to detect one of them, because once that flag is set, it can't be set again until it's reset. And that's what this line does. It resets or clears that flag. Yeah, I'm wondering if it's a set or it's a clear, but anyways, it's going to get rid of the flag that a button's been pressed so that it can look for another button press. Okay, so down here I'm using, up here is if and then else. So either this is going to run or this is going to run. So it's if else. If a button has been pressed, it executes this. If this is not true, then it's going to run this line. It's only going to run one or the other. And so if there's no button pressed, it's just going to print out button 1 off. So that just means on that cycle through the loop, it did not detect the button press. Okay, and down here we're going to check for a button 2 press. So it says up here we're using the Raspberry Pi version of an interrupt. Down here we're using the polling method that we talked about in the first video. So again, if when the program gets to this point, if the button is pressed at this point in the program, then it would be equal to low. So what we're actually doing is we're going and looking at what is the button state right now. And remember, if we push the button, it's going to go low. It's going to take that pin to ground. So if the button is, or if that pin is low, when this line executes, then it's going to go and do this code here. And only if it's occurred, or only if it is actively low at that time, and then it's going to print button 2 is on, just like up here. When this program gets this line, if the button is not pressed at that time, then it's going to execute this line and say the button's off. And again, instead of adding the 500 milliseconds, or instead of subtracting the 5 milliseconds up here, we're adding the 500 milliseconds. So this is going to increase the delay. So button 1's going to decrease the delay, and button 2 is going to increase the delay. So this is going to speed the blinking up. This is going to slow it down. And then once we do those things, it's going to print out what the current delay value is, and so that we can see what we're doing. And then it's actually going to blink the LED. And this is all I'm doing here is I'm doing a GPIO write to pin 18. Remember, LED is equal to 18. And then this is the value we send to that, and it's only going to be a 1 or a 0. Now we could put we could use some kind of control structure here, but this is where I'm using the bit mask. I'll go over the bit masks later, but just know that this section of code here is going to alternate between 1 and 0 every time it's executed. So it'll alternate back and forth. And I'll show you how that's done a little bit later. This little symbol here is an exclusive OR logical comparator. And we'll get into that when we go into bitmask. So if you're confused, don't worry, we'll cover that in another video. And then down here, this is where the delay occurs. So whether the LED was turned on or is turned off, it's going to delay for whatever the current value is. and that's about it. And this line should never really get to this line, but if it does, it'll just end the program. So this is actually just going to loop over and over again. So let's go ahead and run this and, and see how it goes. Okay, now you can see that this is printing out to the screen, and here we're seeing button 1 state is off, button 2 state is off, and the delay is 5,000 milliseconds or 5 seconds. Now I'm going to start by, I guess I'm going to start by pressing button 2, which we said increases the delay. And watch what happens when I do that. You can see that nothing's happening. It did not detect a button press on button 2. Is there something wrong? No, it's doing exactly what we told it to do. Now watch if I press and hold button 2. As you can see, if we press and hold button 2, both the button 2 says that report here says it was on, and that and then the delay increased, and that's because we're using the reason why it didn't work up here is because we're using the polling method, and in the polling method it will only detect that button press if it's present when the program checks for it. So let's try it with the Raspberry Pi version of the interrupt method. Now remember, let me just push the button and show you. You can see I pressed the button several times there, and it did detect the button was on, but it only reduced the delay by 500 milliseconds. Now let's reduce it a little bit more. Okay, now you can see that as that while it reliably detected the button press, it still will only accept one button press for every loop of the program. And that's something that's a little different from the traditional type of interrupt. In a traditional type of interrupt, the program would immediately branch to the code that executes what's called an interrupt service routine, and we could decrease that value on a single line of code, and we could push that button most likely as fast as we could possibly push it, and it will change that value that fast if we had a traditional type of interrupt. But in the interrupt we're using here, it's kind of a hybrid between the interrupt and polling method. The interrupt does set a flag that says that an input was detected, but it doesn't. But that's the extent of the interrupt service routine. It takes us actually polling to check that flag to actually change the value. And so let's go ahead and increase the delay again, just kind of play around with it. Okay, because it's blinking fast now, it's a little bit more reliable to pick up that press, but it quickly becomes less reliable as the delay increases. So if you have a program where you don't have a lot of delay in the loop, if the loop that you are using happens say within a few milliseconds, then the polling method might work just fine, because you can only press that button so fast, and if the loop runs in 10 milliseconds, there's a really good chance it's going to detect the button press. But if you have a program that's looping like in this several seconds, there's a very good chance you're not going to detect that button press unless you hold it down. So that's the differences between an interrupt type input and a polling type input. And that's about it for this video. In some future videos, we'll talk a little bit more about the control statements we use, like the if-else statements, and talk about the logical operators and the bit mask like I promised. So check back soon, and we'll talk again soon. If you like this video, please click like. It motivates me to make other videos just like it. If you want to find out when I post more videos, please subscribe. You can also read about completed projects on our website, spaztech.net or spaztech.com. On our website, we include details of how we did some of the projects that are on these videos and some of the source code that you can use yourself as much as you like. If you want to track progress of projects we have going on step by step, be sure to check out our pages on Twitter and on Facebook.